Kinetics is all about how chemicals respond when they interact with each other. For a chemical reaction to occur, the reactants must physically collide with each other to form the product. If no collision occurs, there will be no reaction. The same goes if the collision occurs unsuccessfully. This is called the collision theory and is what everything in Chemistry 12 is based off of. Reactions are occurring constantly in nature. However, most reactions are so slow that it takes years for anything to really change in the environment. Kind of like how the Sphinx in Egypt is being destroyed by acid rain over the centuries. This is an example of a relatively slow reaction. Generally, people want reactions to go much faster so they can see the results of their efforts within their own lifetime. Reaction rate is controlled by the slowest step, kind of like a weak link in the reaction. This is why when chemists speed up reactions, they target this weak link. Factors affecting reaction rate are temperature, concentration, surface area, and a catalyst. In a more relatable setting, you can think of reaction rates as a group of people in a room. Every time two people bump into each other and fall over, a reaction has occurred. However, the reaction doesn't happen very often because the people are moving slowly, so you have to do things to speed them up. For example, if people have more energy and were running, they would likely hit each other much more often and fall more frequently. This would be like adding temperature. Another way is putting the same amount of people in a smaller space. This would increase the concentration and make collisions more likely. A catalyst would be like giving everyone a few beers. They wouldn't need to bump into someone else very hard to fall over. The other aspect of kinetics is EK distributions. In a sample of matter at a given temperature, each particle will have a different amount of energy, and only the particles with the most energy can reach EK and react. Increasing the temperature increases the EK, therefore allowing more particles to reach EK. As two particles move towards each other to collide, their charges repel, turning their EK into EP. As long as they have enough EK, the collision will be successful. Most reactions are reversible in theory. It's like basketball. The person with more energy will have an easier time getting the ball in the hoop, but if heat is applied, the person with less energy will see a greater benefit.